So we had it started with this correct structural formulas. We did that, and we did isomers, how to make isomers, and we discussed all of that. करना क्या है कि अच्छा अच्छा तो करना क्या है कि what you're supposed to do is change the arrangement of the atoms, but keep the same number of atoms. So we learned all of that, and we learned what is not an isomer. वो सारा हमने किया था. और फिर था कि so and then we had started doing the homologous series, which was I told you that since pretty much all living organisms and everything, there are billions of different organic molecules out there. तो अब उसमें ये कि since there are so many organic molecules, so since there are so many organic molecules, different organic molecules, so you need to classify them. You need to classify them so that you can guess what their properties are. Okay, just like in an animal kingdom, if you say that something is a bird, you pretty much know what it looks like, what features it's going to have. So we need to classify these molecules so we can give them names so that we can figure out what their properties are just by looking at the name. So it's a homologous series is a classification system. It's a family of organic compounds, and you put them in the same family if they have similar chemical properties. They've got the same type of chemical reactions. That was the first one. Okay, so similar chemical reactions. So then we talked about them having showing trends in physical properties, which wouldn't be exactly the same, but there would be trends, and they have the same functional group, which I told you was a structure or group of atoms in a molecule that determines its chemical and sometimes physical properties. So we discussed कि अगर ये molecule है, so what's going to happen is that the molecules chemical properties are determined by this thing, not by the rest of the molecule. That pretty much does nothing. It's only a bunch of atoms in the molecule that kind of determine what it would react with. So that's how you just 1 second एक message कर लो. See, Baki, this is still not over. You're going to get questions on this. The other points as well, that molecules. So the other factors as well. So one of them is that if they're in the same family of compounds, they're going to have the same general formula. And I'm going to talk about the general formula and these last 2 points once we start doing with the first homologous series. And there's another point, which is that successive members differ by successive members they differ by a CH2 group. Okay, we're going to do the first. So remember all these 5 properties. They're going to ask you about these properties. Now, the very first homologous series of family of compounds that we will study, those are your alkanes. So alkanes are the first homologous series. And what alkanes are we need to figure out which molecules are alkanes. Alkanes are those organic molecules. First thing is they are hydrocarbons. A hydrocarbon, what that means is it only has hydrogen and carbon atoms. It only contains hydrogen and carbon atom, and that's it. The second thing is that they are saturated molecules. So what that means is that the word saturated, what that means is that they all bonds are going to be single bonds. So all of the bonds are going to be single bonds. So that's what alkanes are. So make any molecule that first thing only contains carbon and hydrogen atom, that's it. And they would only have single bonds, that's it. So you can make any molecule, any random molecule, whether it contains 2 carbon atoms or 5 or 6, whatever, that is going to be an alkane. So I'm just randomly drawing or connecting carbons and hydrogen atoms. This carbon, every carbon should have 4 bonds, but make sure every bond is a single bond. So this is one example of an alkane. You could have a smaller alkane like just 2 carbon atoms. So that is also an alkane. Or you could have the carbon atoms connected in a cyclic structure. That would, so that one would also be an alkane. So all of these are alkanes. So that's what an alkane looks like. So whenever you see a molecule that contains only carbon and hydrogen atom, and it only has single bonds, that is what an alkane is. So I'm going to come to the first thing, which is naming alkanes. So we're going to learn how to name alkanes, and we're going to learn how to name pretty much any other molecule as well. So every organic molecule is named or has a prefix, and it has a suffix. It has a starting name and it has a name, an ending part as well. So every molecule has 2 things, a prefix and a suffix. So for an alkane, the suffix is always A-N-E. It's always going to end with "-ane". The prefix could be many, and the prefix can be meth, eth, prop, bute, pent, and let's keep it till hex. So those are our prefix. ठीक है मिनाइल, बोर्ड का लिंक just a second. Achha, so this one, so every organic molecule would be named in this way. It's going to have a prefix, it's going to have a suffix as well. And what will happen in that is, okay, what's the prefix? The prefix represents the number of carbon atoms. 1 means it only has 1 carbon atom. Meth means 1 carbon atom. Eth means 2 carbon atoms. Prop means 3 carbon atoms. But is 4 carbon atoms. Pent is 5. And you've got hex, which is 6 carbon atoms. And so on. I mean, there are other prefixes as well, but you just have to remember the first four or 5. At best, you should remember 6. And only naming of simple molecules. Only simple straight chain alkanes need to be named. Or complicated naming is not part of your syllabus. So you just have to, when I say straight alkanes are, it's just the middle one. This is not a straight alkane. The carbon atoms are arranged in a branched manner. So remember, branched molecules, their naming is not in your course. Similarly, cyclic, that's not in your course. The only ones you have to remember naming about is the straight chain ones. So we're trying to learn how to name them. So remember, all alkanes would end with "ane," and they would have a prefix which would be meth, eth, prop, but, pent, and hex, depending on the number of carbon atoms that they have. So I'm just going to revise what an alkane is. Okay, it's a hydrocarbon, contains only hydrogen and carbon atoms. It's a family of compounds that contain only carbon and hydrogen atoms, and all bonds are going to be single bonds. So I'm going to draw a molecule now. And first, let's try and name, because we've drawn these molecules. Let's try and name one. So this molecule over here, it's got 2 carbon atoms. If it's got 2 carbon atoms, its prefix is going to be eth. So it's going to be eth followed by ane, because it's an alkane. So the name is ethane. I'm going to draw butane now. So butane is, but indicates that it's got 4 carbon atoms. Like you can have a look over here. But means 4 carbon atoms. And the ane part indicates that it's an alkane. So it's a 4 carbon atom alkane. So you can draw this molecule. So that's 1, 2, 3, 4. And you can complete the bonds. Every bond in an alkane should be single bonds. Every bond should be a single bond, and that's what your alkane would look like, specifically butane. Similarly, we can talk about pentane. Let's just hold on 1 minute, Azan. Okay. अच्छा चलिए ठीक है, let's so we were talking about pentane, and pent simply means that there are 5 carbon atoms, and ane means it's an alkane, so that is what an alkane is, a 5 carbon atom alkane. Saturated molecule, that means all bonds are going to be single bonds and it's only going to contain carbon and hydrogen atoms. But with pent, it just means that there would be 5 carbon atoms. One more, let's talk about methane. So methane, what does meth indicate? Meth indicates that it's got only one carbon atom. This is meth. So that's 1 carbon atom and it's an alkane. So since it's an alkane, that's it, 4 hydrogen atoms. So all of these are alkanes. Okay, is this clear? Salim, is this clear? Hamza, is this clear?
Yes, sir.
Achha, so that's alkanes. Okay, just remember that if somebody talks about hexane, you should know what hexane would look like. So all alkanes, just carbon and hydrogen atoms. And there's another type of formula which is known as the condensed formula. So we're going to do that as well, which is that drawing all the atoms is kind of time consuming. So for example, over here, you can see drawing this molecule takes a lot of time if you draw everything, like draw all the bonds. So there's another type of formula which is kind of a condensed version. What you do in that is you look at the first carbon atom and you see what's with it. There are 3 hydrogens with it, so it's C with 3 hydrogens with it. Then the next one, what's the next carbon atom? That is C with 2 hydrogens, so that's CH2. Then you have another carbon, and that's with 2 hydrogens as well. And then you've got this last carbon, and that is with 3 hydrogens. So that's another way of writing formulas. Or you can even stop showing the middle one. It's what you can do is you can even condense it further. So CH3, CH2, CH2, and CH3. Now, all these formulas, they do give information about the structure. All 3 formulas are exactly the same, except this is a condensed version, that is a displayed version where you show all the bonds. Similarly, for this, what you can do is instead of drawing and showing every bond, start with the first one. It's carbon with 3 hydrogens. Then you got carbon with 2 hydrogens. Then you got another carbon with 2 hydrogens. Then you've got another carbon with 2 hydrogens. And then you've got a carbon with 3 hydrogens. So that's another way of writing these formulas. It's a bit quicker, but that is also very often followed. So for example, if I want to draw hexane, so hexane is 6 carbon atoms. So it's 1, 2, 3, 4, 5, and 6. Instead of drawing all the hydrogens, the first one should have 3 hydrogens. So CH3, this one is already making 2 bonds, so it should be bonded to 2 hydrogens. This one should also be bonded to 2 hydrogens. This carbon over here, it's already bonded to 2 carbon atoms. I mean, either you can draw the 2 hydrogens, which kind of takes time, or what you can do is you can just put 2 hydrogens next to it. This carbon is also going to be bonded to 2 hydrogens. And this last one would be bonded to 3 hydrogens. Is this clear? You clear?
जी sir.
Achha, and you can obviously get rid of the middle one as well. CH3, CH2, 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 and then I think another CH2 and then CH3. So anyways, but the thing is, when you show all the bonds, I mean, drawing this, like the condensed version, takes some practice. Because if you draw the whole molecule, you can spot any mistakes you made. It's much harder to spot mistakes when you condense it. So anyways, that's your alkanes. Now, there were 2 things that were left in the homologous Cs which we did not discuss. And those 2 things were that a homologous Cs or family of compounds, they should have the same general formula and the successive members should differ by CH2. So alkanes have a general formula. And that general formula is, and you can use that general formula as well. So the general formula of an alkane is CnH2n plus 2. What this indicates is that the number of carbon atoms, the number of hydrogens should be double that. Like if they are 5 carbon atoms, then the number of hydrogens should be 5 into 2 plus 2, that's 12. If they are 6 carbon atoms, then the number of hydrogens should be 6 into 2 plus 2, that would be 14. So for example, here's a molecule that's in front of you. I'm going to use the general formula, which is CnH2n plus 2. That's a general formula. So how many carbons I've got? I've got, I think in this one, I've got 5 carbon atoms, so it's 5. So N is 5, so H would be 5 into 2, that's 10. 10 plus 2 is 12. So that is the formula of this molecule. You can even have a quick look. It's count all the hydrogens, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, and that's 12. You can apply the same general formula to this ethane molecule. So that's C2, Cn. H is 2n plus 2, yani 2 into 2, 4, 4 plus 2 is 6. So C2H6. And you can have a look at C2H6. So general formulas only work for simple molecules, like the simple straight chain alkanes. I mean, even for hexane, the general formula would be what? It's going to be CnH2n plus 2. Over here, since it's hexane, the carbon atoms are 6. So it's going to be C6, and H would be 6 into 2 is 12. 12 plus 2 is 14. So you can have a look and count it. It's going to have 14 hydrogens. Okay? ये clear है सारों को? General formula. Yes or no? Is this clear? अच्छा अब ये है कि अच्छा now the thing is that the last point about the homologous Cs, that they have the same general formula, that's fine. The successive members differ by CH2. So that means successive members, like if you have a 4 carbon atom alkane, you've got a 5 carbon atom alkane. The difference that exists between them, that difference is of CH2, which means there should be a difference of 1 carbon and 2 hydrogen atoms. So you can have a look. There is obviously a difference of 1 carbon, that's fine. But there's also a difference of 2 hydrogens as well. I mean, the only difference between this and this is that in this molecule, there's an additional CH2 that's added. That's it. Like if I remove that part, both molecules would be exactly the same. So the difference between the two molecules is of 1 carbon atom and 2 hydrogen atoms. I mean, this one is C4 and H10. Whereas this one is C5 and H12. So the difference that they have between them is of 1 carbon and 2 hydrogen atoms. So it's a CH2 difference. So that was the alkane homologous Cs. We're going to move towards the alkene homologous Cs. अच्छा उसमें क्या होता है? So alkenes now. I'm going to write the general formula first. It's CnH2n. And what is an alkene? An alkene is very similar to what an alkane is, except that I mean, it is a hydrocarbon. Which means that it only contains carbon and hydrogen atoms. And the other thing is that they are unsaturated molecules. So what is unsaturated molecules? What that is that they don't have single bonds now. They contain at least one carbon and carbon double bond. So between the carbon atoms, there's going to be at least one double bond. That's what an alkene is. So it's exactly the same as alkane, except that it's unsaturated. So if you have a bunch of carbon atoms and hydrogen atoms all bonded to each other, and there would be at least one double bond somewhere. So for example, there's a double bond here and you can add in the hydrogen. So this one would have 3 hydrogens. You could have written CH3. This one would have 3 hydrogens as well. This one already has 4 bonds. This one will have 3 hydrogens. And this one has 2 hydrogens because the carbon is already making 2 bonds with the other carbon atom. Anyways, you can figure out the general formula, which is CnH2n, which means that if there are how many carbons? 5 carbons in this case, then 2n means the hydrogen atoms would be double the amount, so it's going to be 10. So it's CnH2n, which means the number of hydrogen atoms are twice the amount of the number of carbon atoms. And you can even count them. For example, if there are 5 carbons, there would be 10 hydrogens. So actually, this one has 6 carbon atoms. So this is actually C6H12. So it's actually C6H12. So it's 3 hydrogens, 3 hydrogens, 3 hydrogens, that's 9, 10, 11, and 12. So now the thing is, okay, how are alkenes named? So naming alkenes. So it's exactly the same as alkanes, except that the suffix, the first part is the same. It's the same meth, eth, prop, but, or pent, or hex, etc. It's the same thing. But the suffix is now going to be, it's going to be "-ine". That's what your suffix is going to be. So the suffix "-ine", the prefix is the same thing. It's the same number of carbon atoms. 1 carbon atom, 2 carbon atoms, 3 carbon atoms, 4 carbon atoms, 5 carbon atoms, and so on. So that's your prefix. So it's exactly the same. So for example, if I start with methane, now I can't have a methane because I need a carbon and carbon double bond for an alkene. I mean, that was the condition for this, that there should be at least 1 carbon and carbon double bond. So you need 1 carbon double bond, at least 1. So which means that the minimum number of carbon atoms needed is 2. So we're going to start with ethene. Now an ethene would have 2 carbon atoms, and since it's an alkene, it's got an ene in its name. It's there's going to be a double bond, and you can add the hydrogens. That's 2 over here, and we can add 2 hydrogens over here. So 4 bonds of each carbon atom are now complete. And is it CnH2n? So N is 2 over here, number of carbon atoms. So hydrogens is 4. So that is fine. So that is what an ethene molecule looks like. Similarly, we can do propene. Now, propene is, prop means 3 carbon atoms. So you're going to have a look up above, that's 3 carbon atoms. And there's going to be at least 1 double bond, and you can add the hydrogen. So there would be 3 hydrogens, and every carbon atom should be making. So every carbon atom should be making 4 bonds. So that's what a propene molecule looks like. You add a double bond, and then you fill in the hydrogens. That's propene. Now, it doesn't matter which where you place the double bond between which 2 carbon atoms. These 2 molecules are exactly the same. I mean, there's nothing wrong with it. They're just, remember I told you they're both exactly the same molecules. Since the connections are exactly the same, like you've got a carbon over here, which is bonded to 2 hydrogens. Remember, twisted, bent, rotated versions of the same molecule are not different molecules. They're exactly the same molecules. So you got a carbon atom that's making bonds with 2 hydrogen atoms. Then you've got a carbon atom which is forming a double bond. You got this one. On one side, it's bonded to a CH3. On one side, it's bonded to a CH3. On one side, it's bonded to an H. The other side is double bond. And then you've got the third carbon atom, which is a CH3. So these 2 are exactly the same molecules. So propene does not have any other version. It's just one propene. Whether you put a double bond here or you put a double bond on this side, there would be exactly the same molecule. There's no difference between them. Structurally, they're exactly the same. They just rotated or flipped around versions. So if I pick this molecule up and I put it the other way around, now they're even more similar. I need to flip it upside down, then it would become exactly the same. First carbon atom, exactly the same. Second carbon atom, exactly the same. Bonded to exactly the same things. Last carbon atom, exactly the same. ये ठीक है? Is this clear? Yes or no? Is this clear? Zainab, is this clear? No, ठीक है. तो ठीक है, alkene से हम कंटिन्यू करते हैं कल. Hamza, I'll just go over your questions now. Just 1 second. Hamza अलग से भेजे थे?
So can you repeat?
नहीं, I'm going to go over your questions. Where did you send your questions? अच्छा, ये वाले. इधर ही कर लेते हैं. अच्छा, ये क्वेश्चन है.
The questions are for percentage yield. Yeah.
ये वाला ना? अच्छा, वो कह रहा है कि एक सेकंड, इसको इधर ही सॉल्व कर लो. Just take make sure you have a calculator with you. अच्छा, so you've got this question which says that the sample of magnesium hydroxide, right, and it's made by adding an excess of aqueous sodium hydroxide to a solution containing magnesium sulfate. So the reaction is that he's got MgSO4 and he's adding NaOH to it. And he says he gets magnesium hydroxide, right? इससे वो बना रहा है. तो दूसरी चीज क्या होगी? I mean, what's left? Like Mg and OH ions get together. I mean, this is ionic precipitation, right? Ionic precipitation में क्या होता था कि if you had 2 soluble substances, अच्छा, if you had 2 soluble substances, तो solution के अंदर they would dissociate. MgSO4 यानी Mg2 plus और SO4 2 minus ions, they would be roaming around. ठीक है, मिनाइल आप दूसरी क्लास के लिए चले जाओ क्योंकि अभी वो वैसी क्वेश्चंस हम डिस्कस कर रहे हैं. ठीक है, अच्छा, you got Na+1 and OH ions and they're also floating around. तो क्योंकि soluble है वो dissociate कर सकते हैं पानी में, लेकिन if Mg and OH ions get together they are solid and they would form a precipitate. तो solution में से वो निकल आएंगे because they would form this solid precipitate of MgOH2 because they are insoluble. और पीछे solution में क्या रह जाएगा? Na and SO4, which would mean कि they would form Na2SO4 aqueous. And you need to balance this, so there would be 2 NaOH and that's it. That's about it. उसने कहा है कि he's using 1.2 grams of MgSO4. Can you find the moles? 1.2 grams divided by mr. Mg 24 होता है, S is 32, SO4 96 होता है total. So अच्छा, so SO4 is 96. ये बताओ क्या आ रहा है 1.2 divided by
0.01.
इसका मतलब है MgSO4 के मोल्स जो है ना 0.01 मोल्स है, राइट?
Yes,
तो
sir.
उसने कहा कि the mass of magnesium hydroxide formed, इसके मोल्स निकालो MgOH2 के, उसके भी मोल्स क्या होंगे? 0.01 मोल्स होंगे, 1:1, राइट? क्लियर है?
Yes, sir. Mhm.
तो अब इसकी मास निकालो, मास क्या होगी? मास
I
इज,
think the ratio is done with the big number, right? Like the one that's in
हाँ
front of mg, not the small. Okay.
हाँ, अच्छा, इनटू MgOH2 की MR कर लो, दैट्स 24 plus 17 34, ये कर लो 24 plus 16 16 32 32 plus 2, that's 34. क्या आ रहा है मास?
So that's 34.
OH twice is 34.
Okay. 0.58.
So you're getting 0.58 grams. अब उसने कहा कि this is your theoretical value, right? Do you understand,
Yes, sir.
do you understand theoretical कि this is the value? कि आपने पेपर में बस calculation किया and you got this value, right? तो
Yes, sir.
he's saying कि he's getting 0.26. So yield is, what is percent yield? The formula, okay, it's the actual. The actual is the experimental, the one that you get in an experiment over the theoretical into 100. तो आपने पेपर में कैलकुलेशन किया, you said कि you should get 0.58 grams. जब आपने असल में कैलकुलेशन की, you were getting 0.26 grams.
Gotcha.
तो कितना है? 44.8.
Yes, sir. Let's see.
ठीक है, अच्छा फिर इसी तरह ना मैं अगला भी कर लेता हूँ जल्दी से. ये वाला है. Okay, what is the percentage yield when 60 kg of ammonia is produced from 60 kg of hydrogen? तो बस 60 kg of उसमें निकालोगे कितना हाइड्रोजन है, तो 60 kg. So
So,
moles
sir,
of,
basically, the mass it's giving is not the actual, like, it's not the theoretical mass. It's giving the
हाँ
actual mass. We have to
हाँ
first find the theoretical by finding.
हाँ, तो इसका करो ना, मास डिवाइड बाय एमआर करो, 60,000 ग्राम्स डिवाइड बाय 2 कर लिया हाइड्रोजन, तो इसके मोल्स मेरे पास आएंगे 30,000 मोल्स आएंगे, राइट? तो पहले थ्योरेटिकल निकालो, तो रेशियो के अकॉर्डिंग टू द रेशियो 3:2, the moles of ammonia should be what? The moles of ammonia should be 20,000 moles, right? क्लियर है? और इसकी मास निकाल लो, mass is हाँ
So basically, the mass that's given in the question is the actual mass,
हाँ
and we have to find the theoretical, and then do the percentageal formula find it.
हाँ तो 17 into 2 कितना हो
Okay.
गया ये क्या होगा 20
So 34,000.
यानी 34 kg राइट
Yes, sir.
वो कितना कह रहा है कि अमोनिया है हमारी तो कम आ रही है it's not 34,000 नहीं it's not 34,000 340 kg कितना आ रहा है
Sir, that's 2,000. It's 2,000 into 17.
20,000
Okay.
340 kg आ रहा है
Uh, it- yes, sir. It's in kg. Yes, sir.
अच्छा आप करो वो कह रहा है कि 60 kg ना 60 kg तो 60 kg एक्चुअल है divide by the theoretical which is 340 kg into 100 what do you get I think it's going to be B
Yes, sir. That's 17.6.
ठीक है चलो ठीक है भाई ओके हमजा
Sir.
ठीक है अल्लाह हाफिज